Now the next example is hydraulic jack. Now this hydraulic jack also based on the principle of hydraulic machine or the Pascal's law. Now this hydraulic jack, these are used to lift heavy vehicles in a service station for repairing. So in a service station for repairing of heavy vehicles, these heavy vehicles are lifted by using a machine called the hydraulic jack. Now follow this diagram. Now how it works. Now this hydraulic jack consists of two vessels, two cylindrical vessels, P and Q. The vessel P is narrow compared to that of vessel Q. Vessel Q is wider, vessel P is narrow. Okay, and these two vessels are connected or joined by a connecting tube known as R. That is, this tube R is a connecting tube between the wider vessel and the narrow vessel. And now this narrow vessel has got a piston A. Okay, it has got a piston A, and a wider vessel has got a piston B. And this piston A is attached with a lever. Okay, it is attached with a lever. Lever is a machine, it is a simple machine. So this piston A is attached with the lever, and this one is the handle. On the handle you apply the force, and the force you apply is the effort. And on the piston B, okay, there is this vessel has got vessel Q has got a piston B connected with the piston B, and it has got a wider platform. On the piston B there is a wider platform, so that on this platform the vehicles are kept. Okay, and now both the vessels are filled with liquid, say water. These are filled with the liquid. So once it is filled with the water, now this handle, by applying a force or effort on the handle, the lever, since this lever is joined with the piston A, now when this handle is pressed down, the pressure is created on this narrow vessel P, and due to that pressure exerted on this vessel P, the water, it moves from vessel P and passes through the connecting tube. Okay, it passes through the connecting tube, and due to the greater pressure exerted on this vessel P, the valve V gets opened. When the valve V gets opened, through this connecting tube, the water passes and gets filled up in the vessel Q. Okay, and therefore what will happen once the water gets collected in the vessel Q, the upward force will be exerted on the piston B. Okay, and pressure will also exert, and the pressure exerted on a smaller vessel will be transmitted equally and undiminished in the piston B also, according to the Pascal's law. So the pressure is exerted here, and this pressure is exerted because of this lever. Okay, since the lever is attached with the piston, and when the handle is pressed down, this piston will move down, and when it moves down, then the pressure will be exerted in the water, and due to the pressure, the water flows. Okay, and the valve also gets opened due to the increased pressure, and from this valve the water enters and filled up in the vessel Q. And once the water enters into the vessel Q, the platform, then this piston will move up. This piston will move up. Along with this piston, the platform or on the platform where the vehicles are kept or rest on the platform, this when the piston moves up, this vehicle will also move upward, and it keeps on moving. Okay, and when the vehicle will reach up to a desired height, when it moves towards the desired height, then you will stop pressing the handle. You will stop pressing the handle. Once you stop pressing the handle, then the vehicle will come in the state of rest here. Okay, and therefore now the vehicle can be repaired. It can be repaired, and therefore what will happen here is that now once the water will enter through this vessel Q, the valve V gets closed. And this valve, once the valve V will get closed, then the water from the Q will not again they will not again come back to the vessel P. That means this valve will prevent the backward flow of water towards the vessel P. Okay, and this vessel get closed due to the equal pressure exerted on the two vessels P and Q. So this way the hydraulic jack it works.